All right, everyone. Next episode here. So where I left off last video was we were talking about inverse sine. I went ahead and wrote down the definition, and also talked about the limitations to the inverse sine's range. So therefore, limitation to sine's domain. So what we're going to talk about today is inverse cosine, inverse tangent. So not today, but this video, same day. But well, might be for you guys, might not. So. Yeah, let's look at inverse cosine, inverse tangent here. So here goes. First of all, here's the graph of cosine. I went ahead and graphed it. This would keep going on and on forever if I wanted to keep drawing it. Looks like a wave. It starts at the point 0, 1. All right, so it starts at a crest. It has the period of 2 pi. It's going to go from crest to crest in 2 pi units. So that's going to be the period of it. Now, amplitude's 1. It's going to go above the what I call equilibrium, up 1 and down 1 below it. So let's talk about this and let's see what we can do with inverse cosine. So just like we were dealing with inverse sine, if I asked you guys, is this a function, y equals cosine of x? What would you tell me? Yes or no? That's correct. The answer is yes, if you said yes. All right, so it passes the vertical line test. Now, the question I'm going to ask is its inverse a function? If you just graph this. And the answer is no. That right there, that horizontal line is going to cross more than one point. It's actually, if it keeps going forever, it's going to cross infinitely many points. So its inverse is not a function right now. So what I need to do is I need to limit the domain of the cosine function in order to make the cosine function, sorry, let me say that again. I need to narrow down, I need to restrict the domain of the cosine function in order for the inverse cosine function, well, in order for the inverse cosine to be a function. Sorry, muddled through that. All right, so what I need to do, let me restrict the domain here. The way we restrict the domain on cosine is going to be from 0, this right here is going to be pi, okay? So all we need to do is restrict the domain from 0 to pi. So that function right there is its inverse a function. Does it pass the horizontal line test now? And it does. Okay, so let's write down here the inverse cosine definition. Another word for it is arc cosine. Okay, I'm going to use inverse more frequently. I like inverse better. Don't know why, just do. So I'm going to use that more often, that terminology. But you could also call it the arc cosine. So the unique angle y and the interval from 0 to pi such that cosine of y equals x is the inverse cosine, otherwise known as the arc cosine, denoted like this. So you can say cosine to the -1 power. Again, that doesn't mean literally to the -1 power. It's just notation saying the inverse cosine. And arc cosine is another way to write that. All right. Okay, so get that down, pause this if you need to write it down. Here is the rest of that, what I want to talk about. So the domain of the inverse cosine is going to be from -1 to 1, brackets on both, and the range is going to be from 0 to pi. So we have to restrict the domain of the cosine function from 0 to pi, and so therefore that makes the range of the inverse cosine from 0 to pi. Okay? So that's the idea. So we can only pick values from 0 to pi. All right. So again, pause it if you need to. I'm going to move on. Just keep the video shorter. So yeah, let's just get to some examples. Okay. So remember, we're going to restrict the domain. Now remember, with inverse sine, we restricted the domain of the sine function to -pi/2 to pi/2, brackets on both. With cosine, we got to look from 0 to pi. So this is going to be a little bit different, finding the inverse cosine instead of the inverse sine. So here we go. Let me bring up another unit circle. I marked on this one. Let me exit out of this and bring up a new one. Okay. There it is. All right, so here we go. So again, the question you need to ask yourself is, what did our angle have to be in order for cosine to equal square root of 3 over 2. Positive square root of 3 over 2. I think it is, right? Let me just double check. Yeah, positive square root of 3 over 2. So what did the angle have to be in order for cosine to be positive square root of 3 over 2? Okay, so let's talk about it. Well, let me talk about it. You guys just listen. Alright, so let's look at the unit circle. Where are cosine values? Now remember, cosine values are x values. So where are the x values? And again, what we're going to look at here is from 0 to pi. Let me throw that away. From 0 to pi. So those are the angles we're looking for, that top half of the unit circle. So where is my cosine values going to be positive square root of 3 over 2? And so if you just look at the top here, the only one that we have is pi over 6. That would be an answer. Sorry, I got birds again. And then the bottom here is going to be 11 pi over 6. Those two would answer the question. Is cosine, sorry, let me say that again, sorry. So again, the question I told you to ask yourself is, what did my angle have to be in order to have a cosine ratio equal to square root of 3 over 2? So both of those angles answer that question, but we can only choose one of them because 11 pi over 6 does not fall in the right interval. We have to choose from 0 to pi. Okay? So with cosine, we got to choose the top half of the unit circle. So we got to pick an angle up here. So in this case, pi over 6 is going to be my answer. Okay? That is my angle. Now, notice I'm writing most of these in radians. Again, I told you I want to eventually move towards radians instead of dealing with degrees. Okay, here we go. Let's keep going. This one's a little different. So we want the inverse cosine of the negative square root of 2 over 2. Okay, so let's try to figure this one out. So again, what did our angle have to be in order to get a cosine ratio of negative square root of 2 over 2? So if you look at your unit circle, cosine, in order for cosine to be, which means x values, to be negative square root of 2 over 2, well, we've got two answers here. 3 pi over 4 and 5 pi over 4. Both of those x values are going to be negative square root of 2 over 2 because those are the middle values that we had to choose from. So if we look at those two, which one should we choose? Which one falls in the right interval? And the answer is 3 pi over 4. Okay. There it is. And let's do, I think I've got, well, I thought I had one more for you. Let me do a tougher one. So part C here. How about I throw a little bit of cosine and sine together here on you? So what if I did inverse cosine of the sine of, sure, 7 pi over 6. Okay. So if you have a problem like this, again, just like we did one of these last video, what you need to do is first do parentheses. So order of operations, do parentheses first. So figure out what sine of 7 pi over 6 is. So this one takes a little bit more work. So what is the sine of 7 pi over 6? Well, let me look at the unit circle again. So 7 pi over 6 is right here. And remember, sine deals with y values. So what is the y value of that point on the unit circle? Yep, you got it. Negative 1/2, right? So that's negative 1/2. Sine of 7 pi over 6 is negative 1/2. So this is the same thing as the inverse cosine of negative 1/2. We're going to try to figure that out. Okay, so this is a little bit simpler problem now that we've figured out what the sine of 7 pi over 6 is. So the inverse cosine of negative 1/2 is going to be, let's look at it. So what did the angle have to be in order for the cosine ratio to equal negative 1/2? Well, there's two answers to that question. Here, that angle, 2 pi over 3 and 4 pi over 3. So hopefully you've caught on by now. Which one of those can we throw out? 4 pi over 3, we throw that out because it's not in the right interval. So 2 pi over 3 is going to be my answer. There it is. Okay, I'm gonna go ahead and stop this video because those are some good examples of inverse cosine. So I'll stop this, and the next one we'll do is inverse tangent.